A dynamo converts mechanical energy into direct current. Its concept was formulated by János Jedlik, a Hungarian physicist, teacher, and inventor. Jedlik completed his dynamo by 1861. The complicated device produced electricity by turning its axle by a crank. At the same time, Ernst Werner Siemens worked on a similar device, which he patented in 1867. Dynamos are still used for powering bicycle lights. A dynamo converts mechanical energy into electric current. This animation demonstrates the process on a simplified model of the dynamo. The armature loop is rotated in a magnetic field which induces electric current in it. The current is utilized for powering a device such as a light bulb. Then it is transmitted back onto the electromagnet. The current in the coil induces a magnetic field which increases the magneticity of the iron core. A stronger magnet induces a stronger flow of current, which further strengthens the magnet. That is, the magnetic field and the electric current induce each other until a maximum voltage is reached. This is the principle of dynamo self-excitation. During the spin of the armature loop, alternating current is induced in it, which is converted into direct current by a commutator. The direct current is then transmitted to an exterior circuit by brushes. The magnetic field induces electric current in the rotating armature loop, the strength and direction of which is shown by the yellow arrow. The black arrow is the magnetic induction vector B. It points from the north pole of the magnet to the south pole. The green arrow indicates the speed of the armature loop. In this arrangement, the current is the strongest when the armature is horizontal. At this stage, the B and V vectors are at right angles. The direction of the current alternates due to the spin of the armature, and therefore a commutator is needed to produce direct current. The current induces a magnetic field in the coil. When we wrap our right hands around the coil with our fingers in the direction of the current, our thumbs point in the direction of the magnetic north pole.